Hello, so let us look at the first question from the year 2010, Form A. Alright, so here I'm going to give you a little bit of time for you to read this question, and then we'll talk about it together. So it says here, there is no snow when snow begins to fall at midnight. So no snow, this basically means the initial condition. When t was equal to 0, it seems like there's no accumulation at all. And we have function f of t, which describes the rate of how much snow accumulates. And t is measured in time, hours. Now, the rate, once again, g of t is how much Janet removes the snow from the driveway, and given in this way. All right, so then I think we are ready to tackle this question number 8. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? So accumulation only is governed by F, so A will be accumulation will be equal to, from 0 to 6, because we're looking at 6 a.m. of f of t dt. Simple as that. So then let's try to look at that for a second here. If I consider y equals as 7x, I'm putting x in place of t here, and e to the cosine of t. Alright, now we're going to set the window since 0 through 9. Okay, let's see what we have. Window is 0 through 10. Okay, that's fine. And as long as mode is also in radian measures. Okay, then let's look into this one together. So I'm going to use a zoom fit, which is 0, number 0 here. That keeps the x value as they are, and then change the y value automatically. So that's what we end up getting. Accumulation from 0 through 6, that can be calculated by second calc. Number 7 right here, that's the integration. Lower limit will be equal to 0. Upper limit will be equal to 6. And there it goes. So the answer was 142.27 cubic feet. Alright, that was part A. Now, find the rate of change. We're talking about the rate itself, rate of change of the volume of the snow at 8 a.m. Okay, rate of the change is governed by two things: how much snow comes down and how much of snow is being removed. So in fact, what we are looking for here is part B. I'm going to put it this right over here. Change, let me call it C of t, is equal to how much of snow is falling, f of t, which is positive value, minus g of t. The difference between those two. So then let's try to calculate this one. C of 8 at 8 a.m. is equal to f of 8 minus g of 8. And we realize what g of 8 is. When t equals 8, g is equal to 108, so that's kind of easy to calculate. How about f of 8? We can go back to the calculator here. The way which you can do it is second cal. What we're looking for is the value, because the function was the rate function, so we just have to get the value here itself. Enter. And then value of x was equal to simply 8. Then there it goes. So there we have we end up getting 48.42 minus 108. That becomes our answer. So I'm just going to go for second quit, and then if I type in y, it should give me the same value. So y is alpha and number 1. That's y, just to make sure and that was the y value that which we just calculated, as you can see, and then minus 108. And that's what we end up getting. So we make it smaller here, and that becomes negative 59.58 cubic feet per hour. Now, rate of the change state basically means it's being removed, decreases by 59.58 cubic feet per hour. That's what's happening in terms of total amount of snow. Now let's look at part C. That h of t represents the total amount of snow in cubic feet. Total amount basically means, well, we have to integrate what was given. So Janet has removed from the driveway from at time t hours after the midnight expressed. So in this case, h of t is the only, we are concerned about amount of snow that Janet has removed. We're not talking about f, but we're only talking about g. Express h as a piecewise defined function with domain 0 through 9. So then what we end up getting is this. Since I'm going to use the green, part C is how much it has been removed. H of t basically becomes this way. We're looking at g of t dt, but we realize that g of t, let's try to look at this one once again. Since g of t was in it had three different cases, 0, 125, and then 108. So 0, 125, and 108. 0 simply becomes, when you integrate this one, 0 is simply 0. 125 is 125t, and then 108 is 108t, both of them plus c. Now, notice, since in this case, initial condition was simply 0, so we're not going to get any value c, but here this value c has to be accompanied or calculated based upon what we have done in the previous case. So let's try to look into that first. Then h of t, first portion, is rather simple. 0, 4, 0 through 6. Alright, now 6 to 7 would have been simply 125t. And we don't have plus c because initial condition was equal to 0, so that's basically what we end up getting, which is 6 to t7. Now, but let us try to calculate this c value. See, due to continuity, one thing that which we get to realize is this. And then another thing which you have to realize is t, since t only works for the 1 hour that's given, what we actually have to do is this. We have to consider when t being 6 being equal to 0. So in fact, this has to be modified into a couple different ways. One way which we can do it is this: 125 t minus 6. How about that? Then when t equals 0, when t equals 6, we didn't begin anything. When t equals 7, then it will give us the values when work done by 1 hours of work. All right, then how about this c value? C value will be the amount of work that was already done after 1 hour of work. So then in this case, if the rate was 125 for 1 hour, then what's going to be happening is this: c value would have been, after 1 hour, it probably finished 125 cubic feet. Now, then in the same manner, what's going to be happening is this 108 and then plus 125. So as just like how the middle function has been expressed in this way, the later term, the final piece would have been also including a style that looks like this. So then this can be transformed into h of t will be equal to 0. From 0 to 6, as we all know, and 125 t minus 6 for t, which goes from 6 through 7. And the last portion becomes 108 and t minus 7, because this will go in fact starting from 7th hour and up, plus 125 for t goes from 7 through 9. That becomes our final answer. Alright, let's look at part D. How many cubic feet of snow are in the driveway at 9 a.m.? In fact, then what we end up getting is this. We have to calculate basically total accumulation. Let's call this one as D. Total accumulation can be simply calculated by amount of snow that it has fallen for f of t dt minus, in this based upon this one, we just have to go for h of 9. Now, then we can calculate the first portion by using the calculator here. And then second, calc. Let's try to integrate this one. Number 7, lower bound was 0. Upper bound now is 9. Then that's what we can realize about the amount of snow that it has fallen down so far. Minus h of 9 is simply, once you plug in 9 in place of t, we get to realize that h of 9 will be equal to 108 times 2 plus 125. Now, 108 times 2 plus 125. Then we end up getting 341. So our final answer here becomes 341. Then once you subtract them, then we end up getting 28.33 cubic feet has left. That becomes our answer. Alright, great. I'll see you guys later. Bye-bye.